Steamboat Geyser right here. Hold on, I'm having some problems with this. So let's go to Steamboat Geyser right here. This is the past several days. This is how it's normally supposed to be here, with cyclical up and downs. Usually following a major eruption it becomes more cyclical, but I don't see that cyclical pattern here. I mean, there might have been an eruption, looks like there was, but let's see, the past 24 hours. Look at that, 60 degrees. Yeah, apparently we did have an eruption, but it did not equalize the pressure at all. In fact, we did have an eruption here, looks like earlier, but let's look at the seismograms here, see if we actually did have an eruption. And let's see. Looks like, yeah, there was some activity. Might have been some small eruptions. But here it shows no activity. Maybe that was it here, but not seeing anything there. So temperatures are still fluctuating at very high levels. Still fairly high, and there should be an eruption very shortly. But the fact it reached over 60 degrees centigrade is very impressive. Look at that, the past 30 days is how it is. See? Right here, look at that. Boom and then eruption, boom and then eruption. I mean, look at that. And it's getting fairly active. I mean, look what happened here. As you can see here, there's a cyclical pattern of every 7 days. So you see right here, you get a pattern of 3 days of activity, then you have an eruption. 3 days, 2 to 3 days of an activity, and then you have an eruption. So right now, we're already pretty extended. We should have an eruption within the next several hours. I think before 2 a.m. we will have an eruption, guys. I think in the next hour or two, we will have an eruption. Like, it's really, really close to an eruption. This is how Steamboat is supposed to normally be, but the fact that it's doing this right now, it's definitely going to have another eruption. So after an eruption becomes more cyclical, eruption and cyclical. Well, this is an heightened activity before the eruption. This is temperatures here. So Steamboat is definitely about to have an eruption. In fact, I'm going to just... Right now, we don't have much to track weather-wise, so... What? Oh, hold on. Change thumbnail. Safe. All right. Alrighty, guys. So let's see if Ben Ferriello has made a video. See, that was pretty... Well, wow. Guys, I don't think Steamboat is going to erupt now, like right this moment. I think it's going to erupt by early morning. Let's see what Ben Ferriello has to say, because yeah, I should have...
Here once again, YouTube. Now, just a quick update about Steamboat Geyser real quick. I said it was going to erupt today at about 6 a.m. to noon time. for September 9th. Right now is 7:07 p.m. Pacific Time, September 9th, 2019. And I said that because of the precursors that were showing on the temperature plots. But it seems like I was wrong. No steamboat eruption has happened yet today. It might happen by the time I get this video up, but I'm probably suspecting it's going to be tonight. I think I anticipated a little too quickly for the precursors on the temperature plots, because it hasn't been a full 7 days, and it usually erupts around 7 days or so, every 7 days. So it has not erupted yet. I was wrong. Wrong. Yes, I was wrong, and I'm willing to admit it. Now, going to my website, you'll notice if you're on here, some of your links may be broken if you bookmark a few things, because I have moved some stuff around. So just come to my website, and everything's still on there. I haven't deleted any pages that you guys are used to, but I put them in different sections. I have a Yellowstone section now with my Yellowstone blog, and the other pages are about Yellowstone, including Steamboat Geyser eruptions for 2019 and 2018. Then I have the Hawaii section with my Hawaii blog, and a page dedicated to spasmodic tremor in Hawaii and what it is and how you can monitor for it yourself. Again, I redid the retrieve seismic data portion, including 13 simple steps to download seismic.
Let's go back to seismograms. Let's see. Still nothing. Completely blank. No activity right now. The past 24 hours, not showing any signs of an eruption. I think it will erupt around this time between 9 and 12Z. That's when I think it's going to erupt. Yep. So this is why Ben thought it was going to erupt. I mean, look at that. It spiked right up to 60 degrees centigrade. Well, now I'm gonna change some gears, and we're gonna look at the tropics right now. The GFS has definitely been scary the past several days, showing Florida impact and all that. I mean, the current GFS is not that scary, has it going out to sea, but still. This GFS is that is a close call, guys. I mean, that is a really close call. Even then, it's going to be really stormy in Florida. I'm going to enjoy this. There'll be a lot of water spouts and stuff like that. Especially... yeah, it's going to be fairly stormy in Florida. There's only one model, guys, and all the others are showing a lot of bad weather. Only one of the models has it going out to sea. The other models, guys, up the coast, like nearly all of the models have the storm going up the coast. This is looking at 18Z. This is for what will be Humberto. I mean, look at this, guys. Jesus Christ, look at this. Some of them, look at this model here. Bring it right into the coast. Look at that. And look at this model, ensemble member 3. Almost seeming like it's gonna go off the coast and zigzag. I mean, this is crazy. Look at this one. Just like Dorian almost. Well, except it takes it inland, so. See this one right here? Seems like it's gonna go out to sea right here. You see that? Northeast movement, but you see that high over here, so. Bam. Right in Miami. This one hits Miami and then hits New York, or brings it very close. If this happens, I'll be like, oh, we gotta go to New York, and then boom, it's gonna come to New York too. So guys, this is very scary. Yeah. Alrighty. So let's go back looking at Steamboat Geyser. Oops. This is GPS showing the deformation. Yep, deformation the past couple of years. Look at that. From 0 to 5, that's centimeters. So that's 5 centimeters of uplift in only 2 years. And looking at that, centimeters to inches, that's 5 centimeters. That is 1.5, that's almost 2 inches of uplift in only 2 years. Actually, let's go to meters to centimeters. Meters to inches. That's 0.05. 0.05. Yep. See that? 1.96. So yep, that is 2 inches of uplift, guys. It's 2 inches of uplift in only 2 years. That's pretty high. That's quite a bit of uplift, guys. And it looks like the uplift is oriented more up. Because let's see, 0, 0, or negative 0.2. Uplift is more towards the south. So it's more south. South. Yeah, it's more southeast, I guess. Southeast oriented uplift. And if you want to take it from 2015, that is about 0.09 centimeters of uplift. That's I'll say 0.09. That's about 9 centimeters. That's 3.54 inches of uplift. That's pretty fast. That's some pretty good uplift. Alrighty, let's look at others. GPS deformation plots here. Alrighty, let's look at. Thing is, most of the area, yeah, it's cyclical. So no uplift or subsidence here. It's pretty normal zonal. Yep, normal. And let's look towards Mallard Creek. No, that's pretty far north, and in fact, it's actually more subsidence actually. It can't. I know you probably guys can't see it, but there's subsidence. Alrighty. Looking at Yellowstone Lake, LKW, or actually GPS P709. Some slight uplift, but not very impressive. Uplift is very slight. Like in the past 12 years, hardly any uplift. So nothing. Only uplift I'm seeing right now is some uplift at Norris. That's about it. And YNR is having uplift. Yeah, the only uplift I see is YNR, which is Norris. So from about -4 centimeters to, I would say, 0.7. So actually it's from -4 centimeters to +7 centimeters. That's going to be, let's see, if I do the math correctly, that's going to be 4 centimeters to 0 plus another 7. That's actually 11 centimeters of uplift. It's actually 11. It's actually a little over 4 inches of uplift. But the thing is, at the same time, and then it falls back down, and it's right around 5 centimeters. And there was a pretty big spike in uplift here in 2014. Let's see if that was. Yep. Investigating rapid uplift and subsidence near Norris. That's hydrothermal. Although Yellowstone's last magmatic eruption occurred about 70, Although Yellowstone's last magmatic eruption occurred about 70,000 years ago, hydrothermal explosions, earthquakes, and ground deformation still occur as testament to ongoing volcanic and tectonic processes. Since the late 1990s, a network of continuously recording global positioning system receivers has recorded uplift and subsidence of the caldera and northwest caldera margin near Norris Geyser Basin. Previous deformation episodes have shown opposing vertical motion at the two sides, which has been attributed to temporal variations in magnetic fluid flux from the caldera. From uplift laterally through the Norris Mammoth Fault corridor that intersects the caldera's northwest margin. These episodes have exhibited gradual changes transitioning from uplift to subsidence and vice versa over weeks to months. Large earthquake swarms accompany transition from caldera uplift to subsidence in 1985 and 2010. Recent deformation in Yellowstone differs from previously observed episodes. In the latter half of 2013, uplift began around Norris, and by January of 2014, it reached rates of over 15 centimeters per year. Also, at the start of 2014, caldera deformations shift from approximately 4 years of slow subsidence to slow uplift. On March 30th, 2014, a magnitude 4.8 earthquake, the largest in Yellowstone since 1980, occurred northwest of Norris Geyser Basin near the center of uplift. Since shortly after the event, deformation near Norris abruptly reversed to rapid subsidence over 20 centimeters per year. Caldera uplift began to accelerate around the same time. Thus, uplift can occur simultaneously in both the caldera and the Norris area, and dramatic reversals from rapid uplift to rapid subsidence can occur within a matter of days. While the complexity of the deformation defies a simple explanation, we hypothesize that the rapid transition from uplift to subsidence at Norris may indicate that the 4.8 earthquake opened a pathway for fluid migration away from Norris and allowed an increase in fluid flux beneath the caldera, which basically means that more magma may actually be entering the system, or it could be hydrothermal, not magmatic. And there we go. Let's see if that changes anything. May actually be entering the system, or it could be hydrothermal, not magmatic. Okay, guys. Oops. Okay. Alrighty. Alrighty. Still no eruption. And let's look at weather.cod.edu. It's probably up to hour 20 right now. 48. Let's check short term if there's going to be any storms in the northeast. Looks like Thursday or Wednesday night there might be some storms. There will be Humberto. And look at this model right here, guys. This is a very scary model. This shows a catastrophic hurricane, a very powerful hurricane, passing closer to northeast. You know, so this is a pretty scary situation. This is a scenario that leads to storms like the 38 New England hurricane. Basically, a very deep trough, area of high pressure that could get funneled northward. And looking back at Yellowstone, no change, okay. So no eruption. Now let's look at magma Indonesia, guys. Let's look at volcanoes in Indonesia to see if they're erupting now. No eruption. This is because of mining activity, guys, so nothing impressive here. There could be some magmatic activity at Batur. I mean, this did have a caldera forming eruption several thousand years ago, so. But did I just close out? Okay, so that's what I closed out. Okay, good. Good. So nothing impressive here. Gamalama activity wiped out. Can't see anything there. Problem with the web recorder. Activity is continuing. In fact, there's actually a cessation of eruptions here. There's a big eruption, several big eruptions at Gamalama. Actually, no. Sorry, not Gamalama. Sangyang Api. Let's see if there's anything on the news there for that volcano. Volcano. This is what it usually does. This is the eruptions you usually have. Joining the most active in the Lesser Sunda Strait to form the 13. Often effusive. So it's usually Strombolian. Sangyangappi's eruption usually effusive with lava flows accompanying Strombolian activity following an initial explosive phase. Actually, it's not a very quiet volcano. In fact, yeah, this is how that volcano usually erupts. Yeah, it's not an effusive eruption. So every time you see one of these here, 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 there, here. Those are actually eruptions. Oh, wow. That's not good, guys. Look what's happening at Rinjani. Yeah, Rinjani is gearing up for an eruption, guys. I'm not sure if those are quakes or that's an eruption. So I'm going to have to check. There's definitely activity now at Rinjani. But Rinjani hasn't had an eruption in years. Rinjani is still considered a good, like, 2016 had a powerful volcanic explosion. This is the volcano that led to thousands of people dying in England back in 1258 AD. Just and the fact this island had a 6.9 earthquake right on the flanks of this volcano is very concerning. Now let's look at Steamboat again. Alrighty. Still no eruption. Alright. Let's see if there's any earthquake activity. One lone earthquake. 0.2 at 7.5 kilometers in depth. Well to the northwest of the caldera. So, ooh, that's a pretty big quake there. 4.6 in Nevada. And that occurred at 4:25 UTC. Oh, that happened just now. 4.6. Not near any known volcanoes. That's the good news. Alrighty. Coastal junction, so near the lava field. Nothing. 2.5. So looks like activity in the Kilauea is calming down. And also, it's all those deep period earthquakes. That's a pretty big quake, but it's pretty deep, guys. Or not so deep. 20.9 kilometers. And okay, that's not in the volcano. That's good, because there was a 10-kilometer depth earthquake. Yep, there was a volcano earthquake right here, right in the magma chamber. 10 kilometers depth. That is right in the caldera. That is right in the Taupo caldera. the fact that it had a 5.1 eruption right in the caldera is very concerning. Because this is a volcanic lake in that there's actually a So guys, there's definitely a chance that this eruption a volcano may erupt as well, again soon. By soon, maybe a couple hundred years, maybe even another 1,000.
O'clock. 2 o'clock.
Lake Rotorua, that's another caldera. It's another crater lake. Another crater lake. The lake was formed from the crater of a large volcano in the top of the volcanic zone. Its last major eruption was about 240,000 years ago. To the eruption, the magma chamber underneath the volcano collapsed or circuit. Okay. Owing to the geothermal activity found around the lake, including still active geysers and hot mud pools, the lake has a high sulfur content, giving the lake waters an unusual greenish yellow hue. It means it's still active. Less than 25,000 years ago. So, alrighty, let's check. Nothing. Anything happened yet? Still no activity. But it's gonna erupt by, I think, around 7 a.m. my time. This was actually likely weather related here. That was probably earthquake, so this might be weather related, not volcanic. And This is actually a Soma type caldera because Soma type volcano. Because here you have a caldera volcano and another volcano inside. So this is a Soma type volcano, an underwater Soma type volcano. It is unknown when the Brothers volcano last erupted, but the crater wall tells us the eruption was so explosive that it caused the volcano to blow out a caldera. Let's see. Curtis Island. Curtis Island crater. And it's definitely having fumarolic activity. That island is actually volcanic. Yet it doesn't look like it's a volcano, but it is. go back to weather.co.edu. Should be about hour 100 something, between 100 and 150. Yeah, right around that range, 138. Atlantic. Same. Still no eruption.
This is Wheeler YouTube here with an important message. This is NOAA Weather Radio, all hazards, station WXL40. Here is the hazardous weather outlook for the Susquehanna Valley. Today and tonight, an enhanced risk is in effect for parts of our listening area. There is an enhanced risk for strong damaging wind gusts upwards of 70 miles per hour, large hail up to 2 inches and a few tornadoes, with one or interior room on the lowest floor of a sturdy building. Scarsdale, Oracle, Bronxville and Fairfield. Precautionary. Southwestern Westchester, Northern Bronx, and southeastern Rockland County. This is a mass casualty situation
This
of
is New York City.
Chester County in southeastern New York, Northern Bronx County in southeastern New York,
So what do you say?
southeastern Rockland County in southeastern New York, until 7:15 p.m. Eastern Daylight Time. At 6:14 p.m. Eastern Daylight Time, Doppler radar and storm spotters were tracking a very large and violent tornado producing catastrophic damage was located over Parsippany-Troy Hills. Doppler radar showed this tornado moving northeast at 45 miles per hour. Tornado emergency for southwestern Fairfield, southeastern Passaic, east central Bergen, northern Essex, southwestern Westchester, northern Bronx, and southeastern Rockland County. This is a mass casualty situation underway and will likely continue. Hazard type: deadly and catastrophic tornado. Source: weather spotters, public and radar confirmed violent tornado. Locations impacted include Yonkers, Patterson, Passaic, White Plains, Wayne.
This is WABC 770 AM from New York, New York. Severe weather is moving into our listening area as multiple tornado and severe thunderstorm warnings are in effect, including one that is heading directly north of the New York City metro and is likely to move parallel to the Connecticut shore as the evening turns into night. This tornado has a history of producing catastrophic damage and complete devastation, has occurred in several cities in Pennsylvania and New Jersey, including Easton, Phillipsburg, and Washington. We are likely...
Okay, yeah. Alrighty, so let's check if that updated. Okay, we're up to 150 now. Still nothing. Alrighty. Alrighty, guys, it's always time for me to go to bed.
Going to get a new warning for areas east-northeast of the current tornado.
Deadly and catastrophic tornado. Source: Weather Spotters, public and radar confirmed violent tornado. Locations impacted include Yonkers, Patterson, Passaic, White Plains, Wayne, Hackensack, Port Chester,
Look at that.
Bergenfield, Paramus, Ridgewood, Terrytown, Dobbs Ferry, Caldwell, Tappan, Greenwich, Harrison.
Guys, it looks like we might be having an eruption here. Right over here, we might be having an eruption. Beginning stages of one anyway. I mean, look at that. That is definitely not an earthquake. That could be the beginnings of an eruption. I'll have to send this to the Volcano Discovery Facebook page. Interesting activity over whoa. Yeah, that is Popocatépetl. Big eruption. Stromboli. Wow. Yeah, I think this might be it. Let me check one more time. Well, that'll be all. Thank you for all for watching, and good night. Actually, wow, never mind. No, 4 people watching. Alrighty, let's look at Steamboat now. Still no eruption. He'll be continuing for 10 more minutes, and I'll be having to get off. That's not an eruption, though. It was just a spike in temperature. Let's check uplift. Okay, there's slight uplift. Now let's look at Long Valley for now. Let's look at the Long Valley caldera. Yeah, and not near any known volcanoes. And constant uplift. Constant uplift at Long Valley. Even here there's uplift, some slight uplift. Uplift. So in the past 5 years, or 8 years actually, from right around here, from 2013, about 6 centimeters of uplift. Just a couple inches in 5 years. That's slow uplift. It's up. There's uplift, but it's slow. And from 2011 here, -3 to +5. That's about 8 centimeters of uplift. Not too crazy. Oops, that's the seismometer. And look at that. -4, -3.5 to +6. That's about 8 centimeters of uplift. Actually, no, 10 centimeters of uplift, guys. That's... So all of the whole Long Valley caldera is uplifting, guys. There's uplift all along the caldera. Let's look to the west part. Pretty zonal. Some actually subsidence there. No real uplift here. This is well south of the caldera. This is east of the caldera. And this is well on the inside of the caldera. Uplift is also occurring, which is signifying that there's definitely some unrest going on there. Also uplift even outside of the caldera from -4, so -2 to that's 6 centimeters of uplift. And that's outside of the caldera boundaries too. Let's look here. Slight uplift. So all of Long Valley is having uplift. Let's look at Inyo Monyo craters here. Subsidence. No uplift. Looking at the Inyo Monyo craters, there's no real uplift. But there is uplift in Long Valley, which is very concerning, guys. Three Sisters. That's a lot of uplift. That's 30 centimeters of uplift, but that was kind of a fluke there. Where's there we go. That's Newberry Caldera. This is where you definitely want to find out if there's uplift. Very high threat. Most recent eruption 1300 years ago. Newberry volcano is the largest volcano in the Cascade Volcanic Arc and covers an area the size of Rhode Island. Wow, that's big. Newberry was built into the shape of a broadly shield by repeated eruptions of the past 400,000 years throughout its history, eruptive history. Newberry has produced ash, tephra, pyroclastic flows, which is indicative of an explosive volcano, and lava flows that range in composition from basalt to rhyolite, which is explosive. About 75,000 years ago, a major explosive eruption and collapse event created a large volcanic depression at its summit that now hosts two crater lakes. Wow, so this is a caldera. Newberry last erupted 1300 years ago in present-day hot springs, and geologically young lava flows indicate that it's still an active volcano. And it's a very high threat because it has had very explosive eruptions. Now let's look at let's look at Crater Lake, a very, very dangerous volcano. Very high threat. Wow. And people thought that this volcano was extinct. No, it's not. It is not extinct. In fact, it may erupt again. Crater Lake partly fills one of the most visually spectacular calderas of the world, an 8 by 10 kilometer or 5 by 6 mile basin of more than 1 kilometer or 0.6 kilometer deep, formed by the collapse of a volcano known as Mount Mazama during a series of explosive eruptions about 7,700 years ago, having a maximum depth of 594 meters or 1,949 feet. Crater Lake is the deepest lake in the United States. Mount Mazama straddles the Cascade volcanic axis and is a cluster of overlapping stratovolcanoes that is the most voluminous quaternary volcanic system in the Oregon Cascades. The volcano's compound edifice has been active relatively continuously since 420,000 years ago, and is built mostly of andesite to dacite until it has begun erupting rhyodacite, which is extremely explosive because it's rhyolite combining with rhyodacite is andesite combining with rhyolite, so it's rhyodacite, very explosive. About 30,000 years ago, ramping up to the caldera, forming eruption. So definitely has another explosive threat. Crater Lake caldera and the deposits formed by the climatic eruption constitute a natural laboratory for study of volcanic and magmatic processes. Research related to the caldera forming eruption has been of fundamental importance to volcanologists, helping them to understand large explosive eruptions, compositional zoning in magma chambers, and collapse caldera mechanisms. The climatic eruption is also the source of the widespread Mazama ash, a useful Holocene stratigraphic marker throughout the Pacific Northwest, adjacent Canada, and offshore. Even Canada, wow. Very explosive. And let's check out Yellowstone. What is its threat? More information. And its high potential. Oh, wow. They actually ranked it as high now. Wow. Used to be only a or a moderate threat. Now it's a high. That's pretty scary. Actually, no. I think Yellowstone was also ranked high in its previous um, update. No magmatic eruptions have occurred since 70,000 years ago. However, but large hydrothermal explosions have taken place during the Holocene, including near Yellowstone Lake. Uplifting subsidence of the ground surface is centered on two uplifted regions: the Mallard Lake and Sour Creek resurgent domes. Large earthquakes just off the plateau along the nearby Teton and Hegman Lake faults, the latter of which erupted in 1959 with a magnitude of 7.5, causing considerable damage to the region. Yellowstone is presently the site of the world's largest hydrothermal systems, including the largest concentrations of geysers. Wow. Very impressive, too. And let's look at other nearby volcanoes. Low, very low. It's a shield volcano. Mono Lake volcanic field. Moderate threat. Basalt to rhyolite. The most recent eruptive activity took place about 300 years ago when lake bottom sediments forming much of Paho Island were uplifted by intrusion of a rhyolitic cryptodome. Were uplifted by intrusion of a rhyolitic cryptodome. Spectacular 2-foot towers line the shores of Mono Lake. So it never erupted. So this island was actually not an eruption. It was actually an intrusion, under the volcano. So basically, technically, it wasn't an eruption. It was actually a magma intrusion event. And Yellowstone already had that in 2009, 2008, 2009. I've never heard of those craters. Obiki craters? Of course, it's a moderate threat, and it's basalt, so. Let's check out Salton Buttes, which is actually right along the San Andreas Fault. Shouldn't really be much of a threat. It's probably a low. Oh, it's rhyolite. Oh, yeah, that's bad. The fact that it's rhyolite, kaboom. Yeah, explosive. The Salton Sea geothermal field, which constantly produces enough power to supply 325,000 homes, has persistent small to moderate earthquakes related to the geothermal system and movement along regional faults. Monitor activity. The high heat flow from the area and relatively young age of Salton Buttes, however, test the potential for future eruptions. Started explosively, then progressed to relatively gentle effusion of dense, glassy-looking obsidian lava domes. So, definitely has a threat for eruptions. And let's check one more time.
what time? Okay, I'm coming back.
All right, so let's look at. Oops. Yeah, quad state. Pennsylvania, New Jersey, New York, Connecticut. Just last week was the last day of MD80. Oh man.
Thank you.
Take care. Get some.
It is extremely important for me to stand in comfortable shoes and feel grounded.
Okay, let's see now. Ready? So 198. Alrighty. And what does the GFS itself have? Oh yeah, that's right. They have this storm going out to sea. Yep, there's definitely activity starting at Rinjani now. And it erupts every few years, and after that big earthquake, I wouldn't be surprised if it's starting to have some eruptive activity. What in the world? Wow. Alrighty. Can't really find anything on, but this is definitely a volcanic quake. You see how long it's lasting? This is basically a harmonic tremor. See it, the way it starts here. But the fact that it's lasting means it's a low frequency quake. And it likely means that there's definitely magma trying to build into this towards the surface. Alrighty, let's look at here, and it's still showing a 20% chance of development. This one is 30%. Yeah. Let's check. Is it erupting? Nope, still no eruption. And let's go back to Yellowstone. Let's no change. Gabrielle, the 50-mile-per-hour storm, 1,000 millibars, moving northeast at 24 miles an hour, 21 knots. Let's look at Merapi. Can't really find anything, so. I mean, look at that. Wow. July 16th. Simbangla's eruption was actually June 11th. That's actually from heavy rain. And I've been sending all the groups. Yep, that's Krakatoa. Nope, that's Stromboli actually. Alrighty, let's close that out. Okay, guys, I gotta go to bed now. Thank you all for watching and good night. There's definitely gonna be an eruption in the morning, and I will probably do a live stream in the morning. Thank you all for watching and good night.